at the airport in Las Vegas and in Barcelona. I reduced it a little bit, so I took away a few slides. So some of the steps may be a little bit nothing changes because of that, but hopefully the whole thing comes across. The idea behind this presentation is to level set an audience that usually comes from a vSphere background and move that audience for a little bit into what's going on in the industry and what we're doing. So we're going to spend probably half of the time setting the context of what's happening in the industry, and the other half of the presentation is more about what we're doing, like vSphere readiness for the platform and these sort of things. Okay, so very quickly through the introduction, why there is all of these thoughts about microservices and Docker containers, cloud native application, because obviously the industry is changing in terms of how we buy things, but not only how we buy things, like this is what we used to do and this is what we do these days. This is my wife with a credit card and the Amazon Prime account. Not only it is changing on how we buy things, but it is also changing in what we buy, right? So, for example, this is applying both to the business, where, for example, people that are buying and businesses that are buying tractors from John Deere, for example, they're not buying those tractors for the mechanic of the tractor itself, but they're buying these for the application that come with those tractors. And this also applies to us, meaning that this is, for example, a scale that I bought a few months ago. And I didn't buy this scale because of the mechanic of the scale, but I bought it because of the app, the iPhone and Android app that comes with it, so that I can monitor how I'm doing, right? Very badly. But that's pretty much the point here, is that software is into the world, right? So, and software is giving people an edge into winning the business, wherever they are in the business. So software is very trend-centric in what people in most organizations are doing. Now, if we look at how we collectively, the industry, is dealing with provisioning software to the end user, and to Joe Buckley's point, thinking about the end user in mind, it looks like this, right? So there is an IT department that is doing the operationalization of those applications, and there are a bunch of developers contributing to these monolithic applications, because that's where pretty much we are today in terms of the operational model as well as the application architecture. So when it comes to the life cycle of these applications, this is the pace that these applications is usually moving at, right? So very slowly, and we have heard about why that is the case, and the problems that come with it. So in the end, this is what happens, right? So the moment that you have an idea from a development or from a marketing perspective, to the point where that idea hits the end user, it could be like a month or years, right, in these contexts. The new organization, the Netflix of the world, are operating and they are architecting the application in a very different way, right? So if you heard about these microservices, how many of you were in Nikki's session this morning about PaaS? He did a good job of introducing some of these concepts about microservices and cloud-native application. But the idea is that that monolith could be broken up into smaller pieces that are going to be independent and are independent with different release cycles, right? Because not all of those pieces need to move at the very same pace, right? And then the third thing is that everything is automated, right? And we'll get to that point very shortly, right? So this changes pretty much everything in terms of the speed that you can get to the end user, right? So the end user experience really moved from months and years to hours and days. So whenever you hear people talking about Amazon releases, 10 times a day or 100 times a day, this is what allows them to do that, right? So this has a couple of aspects to it, right? Before we get into the more technological discussion, this has more in two aspects. The first one is how do you operationalize this, and the second aspect that we're going to be talking about very quickly is the application architecture. I want to focus slightly more on the operational aspect, because I think that that is even more important when it comes to continuous Docker and applications. So if you look at how we used to do things, and we're pretty much 99% of the organization are still doing things, there is this IT organization that is responsible for defining standards in terms of the base software, OS, middleware, and whatever. And then there is a developer that maybe through what they call an enterprise cloud, which is pretty much a way to get VM on demand. That's pretty much what most of the enterprise clouds are today, is able to build code, right? So think about a jar file, which is the result of the coding of the application that is that this guy is developing. So what happens then is that this guy is taking that jar file and going back to IT saying, you know, can we operationalize this piece of code, either as a new application or even worse, upgrade the old application, right? So at that point, this is what I say, this is where the shit hits the fan, right? Because this is where the problem comes in usually, right? So even though this application was already a microservice, if you do not have a way to get that application very quickly into production, there is going to be a big mess into how you do those things, pretty much manually, pretty much like, oh, we need a change, you know, in production, so this is going to happen like at the end of the month, and maybe it's November 2nd, right? So all this kind of stuff. The other thing that is important to understand, and we will come back to this point, is that most of the non-functional requirement, like high availability, disaster recovery, resiliency of the application, scheduling, optimization, monitoring, and all of this kind of stuff are done at this level, right? It's usually who is running IT that has to find a way to do all of those sort of things that you see at the bottom here, right? So this is the model that most organizations are still using today. The new model, so when you hear about DevOps and all of this terminology here, is very different. So this is based on this mantra that someone introduced many, many years ago of you build it, you run it, you own it, right? So it's no longer the developer is building an application and then someone else is going to run it and monitoring and curate. Is if you build it, you own it, right? All the way to the end user experience. So the model is shifting a little bit, right? So the developer is now even more responsible for defining standards. So if you hear about the challenges in this industry that also the vendors has, that the buying power is shifting from IT to the developer, this is also driven by these new models that we're seeing in the industry, where this guy is going to be more in charge of not only writing the code, but running the code in production, right? So everything that comes with templates, blueprints, obviously the application code, and this other notion of infrastructure as code. If this guy has to run those things in production, he's not going to log in into a web UI and do, you know, click, next, whatever. If this guy is going to create a VPC inside Amazon, he's not doing that through the AWS interface. He's probably using a CloudFormation template or whatever to actually code how the infrastructure works, right? And this is very important when we get to about Docker and containers and these sort of things, okay? So basically the idea is that this guy now is more in charge of delivering that service in production. And that could happen both in the private organization or private cloud, whatever we want to call it, as well as the public cloud. So there is also a shift in the role that is happening right now in this new model, where there is going to be the same guy that is doing what I call the plumbing, right, at the private cloud, in the private cloud space. But there is also going to be someone that has an infrastructure background that is working with this guy, right? So this guy that is responsible for writing the code, and it's also, at least the entire team here is taking also responsibility for doing all of those sorts of things that are very much into the infrastructure space, there is someone in that team that is going to take the lead on the infrastructure side of things, right? So whenever you hear DevOps, that's pretty much, it's not like black and white as you can see on this slide. Every organization has their own nuances on how they are organizing themselves into this new world. But that is pretty much one way to look at this. The other thing that is important to notice is that now a lot of those non-functional requirements like resiliency, scheduling, and all those sort of things are going to be shifted more into this thing here. So how you build an application that is self-healing and highly reliable, it is baked into the application or some of the stuff that these guys are doing at this level rather than being built into this private cloud or into this public cloud. And this is pretty much, very simply, the Amazon model, right? So 5 years ago or 10 years ago when they introduced, well, more than 5 years ago, but if you think about EC2 not being reliable, that is by design, right? Because we have already seen this happening in the industry with the Netflix of the world, that they were not looking for a reliable infrastructure because they were building reliability at this level, okay? So this is what allows them to do things like, these are some of the buzzwords that are circulating right now, right? So continuous integration, continuous delivery, continuous deployment, right? Not all of the people are doing continuous deployment into production, but the most advanced organizations are doing this kind of stuff, right? And then I have this slide to show that if you're not doing those kind of stuff, don't work, because there are people like an organization like the NASDAQ that is not doing those sort of things either, right? So it's very, very advanced stuff, okay? So that's part of the operational model, right? DevOps and how organizations are changing themselves in terms of how I'm running those applications in production. There were a few more slides in the original presentation that I had to cut in the interest of time, but these, in the next slide, talk more about the application architecture, right? So not only the operational model needs to change and the way they deal with delivering things in production, but the application itself needs to change to cope with that different model. So Ricky this morning mentioned and provided a link actually that I should have in this presentation about this notion of a 12-factor app. The 12-factor app is kind of a mantra, I would say, that has been introduced a few years ago by the guys at Ferre that describe how a cloud-native application needs to be architected, right? And which is obviously very different from a traditional monolithic application. One of those factors is, which to me is very important and ties back to this discussion about Docker and containers, is the separation between the capacity that you're consuming from the state, right? So for example, we all know and probably you heard about this notion of paths and capitals, right? So paths are the VMs that you know by name, they have a specific name, they have a specific IP address, they have a specific configuration. If they go down, you need to cure them, right, and bring them up. Whereas the cattle is more a model of there is no state in those instances. If one dies, you don't care, you just bring up another one. So basically the idea here is that the monolithic application and the traditional application are usually mixing state and capacity. So the capacity that the VM is using is very tied to its state, whereas the pattern of cloud-native application, or the cattle, is more precisely defined with a space that has to do with state and data, and another part that is infrastructure and capacity. So I always go back to AWS because I think that it's easier to understand what's going on today, looking at what Amazon has built with AWS to serve this kind of new application. So this is EC2, for example, so completely stateless. And if if you have a bunch of EC2 instances that go down, if you're writing a proper native application, you don't care because you bring up another part of the, and you consume your part of your infrastructure with brand new instances that are going to do pretty much the same thing that the other one were doing before. And in terms of data and state, this is where the DynamoDB, RDS, and these services come in, where you actually save the state, S3, and these sort of services that Amazon provide. So without talking too much about services and product, it is important to understand that cloud-native application, one of those 12 factors is the separation between infrastructure capacity, stateless, and data and state. So most of the discussions about Docker and containers usually happens here, right? The usual Docker demo is, I'll show you how to stand up a web server and how to scale it to 10 containers, right? Because that's easy, right? Because you don't then go balance them, and you do all sorts of things in this part of the slide. This is more challenging, right? There are technologies that are maturing right now to provide persistency to containers and to Docker containers in particular, but this is not the low-hanging fruit, so to speak, about containers, right? So most of the discussion are happening at this stage here. So this is kind of a little overview of what's going on in the industry, and this is more into what's happening from a technology perspective. Just for my information, how many of you have been playing Docker Run? Okay, so very quickly, we'll go very quickly through this slide. This is what we have been done forever, pretty much, like a piece of hardware, a hypervisor, like this here, or whatever, and then a virtual machine that has an operating system and an application, right? What is happening these days is that containers are a hot topic. Containers, most of people should look at containers like a sandbox inside the operating system. It's usually referred as operating system virtualization, meaning that within that sandbox you appear to be running your own operating system, whereas you are actually sharing the kernel of these operating systems here, right? So because of the nature of the thing, and because a lot of people are making parallel between containers and virtual machine, there are lots of discussion about being able to also do this, right? So running operating systems natively on a piece of hardware and running containers to basically ship application inside that operating system. We're not going to discuss this in this session because this would be kind of an hour session on its own. I usually joke saying that you can tune on Twitter during the weekends to hear all the thought leaders talking about whether we should do these and that, right? But architecturally, these are all valid considerations which are kind of out of scope from this presentation here. One thing that is important to understand about Docker and containers is that Docker does not equal container, right? So containers has been around for many years, and Docker is a way to use containers in a very, very easy way, right? And it is very important to understand this. This is not a discussion, you know, an academic discussion. This is important because then when we talk about VIC in the next few slides, vSphere integrated containers, it is important to understand this distinction between Docker and containers, right? So basically, Docker has this magic engine, so to speak, that allows you to create a proper lifecycle for your application, right? But so basically, Docker is a process, is a piece of code that allows you to build your application, to push your application into a registry, to pull the application from a registry, and to instantiate an application. So there is a cool lifecycle that comes with using Docker that allows developers, for example, to be able to easily take their jar file that we discussed at the very beginning and wrap it up with, you know, the the requirements that they have, like a Python version or a Ruby version or a particular version of a middleware that they need to use, right? So basically there is this notion of a registry where you push and pull, and the run in the end is where the containers come in, right? So only when you do a Docker run after having done all of these things, it is when Docker actually instantiates a container and put the Docker image that was in the registry into this container as a runtime environment. But it's only a means to serve a purpose that are using that container. Right? So a container is a mechanism to instantiate the code. And it's a very, very convenient mechanism to instantiate the code. Right? This is, if you ask me, this is the magic of Docker. Do you remember when we discussed the infrastructure as code piece, where now the DevOps team need to take that jar file and package it in a way that they can push into production immediately? This is the magic of Docker. So this is my jar file. This is a stupid shell script that I built, but I built it in a way that requires Ruby and requires a number of other things. So I've been playing like the developer, I'm not a developer, but I went through a similar workflow, even though very simplified, that a developer would need to go through when they have their jar file, so that they are basically coding exactly what you would need to do to take the jar file or this stupid script in this example and put it into production, right? So this is what Docker called the Docker file, which is the input for that Docker build that we saw at the beginning. So you code how your infrastructure and your stack should look like, and then you build a template out of it, right? So then the result of this, when you do a Docker build of this file, is a Docker image that you then push into the registry, right? So very convenient way to create a sandbox and authoring a sandbox. Right. So thinking about what we have discussed so far, both in the last few slides as well as the slide that we discussed at the beginning, one is Docker and containers in general getting so much momentum. Right? So if you think about that, Docker allows you to very fast start a process or a Docker image in a container, right? So in a world where microservices need to come up and down very quickly, this is very convenient, right? So it's a lean, small, self-contained environment, which obviously helps. And as we just discussed, is very DevOps oriented because it allows you to actually code everything, all the way from what operating system you need to use as the base for your image, all the way up to all the dependencies that you have. So it's very, very akin to this notion of infrastructure as a service that we have discussed. Ease of sharing. This is very powerful. You can build your application, push it into the registry, and 2 seconds later you can pull it. It's very, very convenient. Right? So we're talking about the centralized Docker Hub, not the private registry. But it's a very, very convenient way for people to consume each other's works. And obviously it's infrastructure agnostic, right? So this pretty much solves the problem. It's not just for that, but this alone just pretty much solves the problem of most of the developers. Well, it works on my laptop, why it doesn't work on production, right? So if you're able to build that sandbox that can run on your laptop, that has all the dependencies that you need, it's very likely that it's going to run as is in the production environment, okay? And then the last point is, this is very akin to this notion of microservices because everything that Docker is doing this in the context of you should actually run one process in each of the containers. So there are people that are thinking about how to migrate VMs to containers one-to-one. That's not really how Docker is pushing this technology and how the industry is looking at this technology, to be honest. So this is way more akin to this notion of chunking up the application into very small microservices where each one of them is a pod or a container. right? So this is ideal to deconstruct the monolithic application that we have seen at the beginning. So when you think about the architecture of cloud-native application and the DevOps model that we have been discussing at the beginning, I mean, this is kind of matching the heaven, right? So that's why most people talking about cloud-native application and DevOps are also talking about Docker and containers because of this reason, right? Very quickly, I'm not going to cover this. The headline for the next two slides is, it's a big mess, right? Because everything that we have discussed so far is what the engine does, right? So if you now zoom out and you look at what's going on at larger scale, obviously, I mean, there is another slide that I wanted to touch upon, which is using that engine is not enough if you want to put things into production, right? Because obviously you need to do configuration management, you need to apply security, you need to do monitoring, you need to do proper networking and all this kind of stuff that is not very easy to do with Docker and containers per se, right? So there is obviously a huge movement in the industry to try to fill this one, right? All of these challenges that you see on the right-hand side, right? So the picture of the container management industry, we have discussed about this Docker engine thing that allows you to do all those sorts of stuff. This is pretty much what's going on at the moment, right? It is a complete mess. So the simplified version of what's going on, I was trying to capture it in a slide, which is a moving target because it always changes, but what we have discussed is that piece on the left-hand side over there. Docker itself is doing a bunch of stuff to solve some of those production-related problems like configuration management, monitoring, control, RBAC, and all these sort of things. But if you zoom out and you look at what the others are doing, because I mean there are money to be made in this space, so there is a rush to try to make those money is very complex, right? So if you hear about Kubernetes, Rancher, Mesosphere, Marathon, it is very complex. And it's a word that is moving very fast in this space, which is the container management space, so to speak. But it's interesting to note how there are also now challenges to track what's going on at the engine space. So Docker engine is becoming like one of the many engines out there to manage containers. Probably largely the most used one, but there are other alternatives that are coming, like CoreOS or Rocket, OCID, which is a new spec that Red Hat are working on. It's a very complex space. It is a very complex space, and as I said, it's a moving target. There were a few tweets that made my day a few months ago, like, are we at peak of confusion? And someone said, yeah, 5 more schedulers and we're there at peak confusion. That was very interesting. Or the other one, which was meant to be fun maybe, but it's actually the reality, is that it's going to be nearly impossible for people to evaluate and choose a container management platform during the gold rush, because this is the gold rush. A lot of people see this as the next big thing. So the engine, nobody's going to make money on the engine. There are money to be made in the management space of those engines. And this is the gold rush, which means that there is a lot of confusion. So what we're doing in this context to solve some of these problems, right? So this is more what we're trying to implement from a technology perspective to cope with the changes that are happening right now. So forget about the Cloud Foundation things, because that was just instrumental to talk about what we're doing already in this new application space with VMware Integrated OpenStack. There are things that we're doing with serialized automation as well. But what I wanted to talk about in this particular presentation are 2 things. So the first one is vSphere integrated containers, and the other one is total platform, which we will cover in a few minutes. I only have a few slides on each of these just to give you a hint about what they are. Obviously, each one of these two will have like a multi-hours presentation describing more technical details. But let's start with vSphere integrated containers. So the idea of vSphere integrated containers, Amanda was looking at this slide and it was like, oh, this is disturbing. I'm not sure why. I mean, it's a, what do you call it, centaur? Yeah. So the idea why I took this picture is that vSphere integrated containers, and in particular Big Engine, which is the main component of vSphere integrated container, is a technology that allows a developer to use a Docker syntax and Docker API endpoint, but allows the IT organization to continue to use the VM model, right? And I have an example in a few seconds. But the problem that we have seen is that developers want to use Docker, right? And they want to use that richness of the lifecycle that we have described at the very beginning. And IT is just not ready to run in production those Docker images instantiated as containers, right? Because the networking model is completely different, because the management is very different, and they have a very huge footprint, vSphere footprint, that they're happy with. And they see this as a big departure from how they operationalize things, right? So vSphere integrated containers, Big Engine, allows a single entity to be seen as a container for the dev, but as a VM for the IT people. But let me give you an example. So this slide pretty much goes back to what we were showing at the beginning. Remember that Docker Engine is not containers. Docker Engine is that piece of software that allows you to do all the rich life cycle. What we're doing is we keep using the same registry that we used before, but the final Docker run is not instantiating a container, it is instantiating a VM, right? So everything is the same. The only difference is that once we get that Docker image off of Docker Hub, instead of instantiating a container on top of Linux, we instantiate a VM that has that Docker image, right? So from a very, very practical perspective, this is what happens. So this is a problem that a lot of vSphere admin came back to us with, and it's very consistent. I have devs that are asking me to provide a very large virtual machine, Linux virtual machine. I have no idea what they're going to do with that big Linux virtual machine, but I know that a couple of months later, they come back and say, oh, I have like 20 new applications in production on that Linux virtual machine, and they are container-based. And IT doesn't even know how to manage those, how to monitor them, how to secure those applications. So basically what happens here is that the flow is pretty much IT deploy this big Linux virtual machine. They configure it in terms of CPU and memory, like for example 32 gigabyte memory, 8 CPUs, whatever that is. They take the IP address of that virtual machine and they give that IP address to the developer, and the developer are going to use that virtual machine as their Docker endpoint. So when the developer gets that endpoint, they start doing things, well, probably more meaningful things than a force cycle that deploys 10 Nginx web browser. But the idea is that whatever they do, then that happens inside that virtual machine. IT has completely lost visibility of what's going on, right? So they have no idea of what's running here because everything that they do is VM-centric, right? I'm not saying that it's the right thing to do. I'm saying that they have operationalized a VM-centric world, and they know how to do that, right? So for those customers that are happy with that model, they want to have a more VM-centric model without breaking the need for the devs. We have created Big Engine. So Big Engine has a different model, right? So instead of provisioning a big Linux virtual machine, what we're doing is we're provisioning what we call a virtual container host. I'm not getting into the details of how you do that and all the nuances, but think about that as a resource pool or a VM in vSphere, right? Being in the VM or a resource pool, I can set the size of it. And I can set it to be 32 gigabyte and 8 vCPU, for example, or gigahertz in terms of power. We are, as part of the virtual container host, we are deploying a very tiny Linux VM, which is a proxy VM that allows the dev to talk to that VM with Docker language and then use the capacity inside the virtual container host. So the flow is that I'm going to take this IP address of this tiny VM that I deployed as part of this virtual container host, and I'm going to give these to the developer. They're going to run the very same command that we have seen before, so a for cycle that deploys a number of Nginx Docker images. But those Docker images, instead of being instantiated as containers on top of a Linux OS of some sort, they get instantiated as VMs, right? So you're not breaking the interface that the development team requires, and you're not breaking your operational model, because this remains a VM-centric model, okay? So that's pretty much at a very, very high level how vSphere integrated container engine works. Now the VIC product, which is part of vSphere Enterprise Plus, also includes other modules like hardware, which is our registry, so that you can instantiate a local registry in your infrastructure, as well as Admiral, which is another piece of software that we developed in the context of VLA, but we can also instantiate standalone, and we're allowing VIC users to use as well. But I wanted to focus more on this side of things because that's part of the, it's a big thing of VIC, in my opinion. Is there any question around this? Is it clear? Obviously, as I said, we could spend like 2 hours to get into the weeds of how this works, but this was more like a high-level discussion. In the interest of time, I'm going to go very quick with this, but basically the idea is that we're not running Docker inside those VMs. So these VMs here, they're not running Docker, or they're not running that application as a container inside that VM. So basically what we're doing there is we take PhotonOS, our Linux distribution, we reduce it to like, just the kernel of it. So we pretty much are doing like 97% or more of what PhotonOS does. So we just take the kernel of that VM. And then we go and grab that Docker image that you could also instantiate as a container. But we grab that image, the exact same bits, and then we plug them on top of that little VM with that little kernel. And that Docker image doesn't run as a container inside that VM. It just runs as if it was an OS inside that VM. Okay. This is a note just to say that there is no software container layer inside the VM. You just run it as if it was an OS. So that's part of vSphere integrated container, right? For those customers that have vSphere, they have operationalized on vSphere, they want to maintain the vSphere view of the world, but giving the Docker-centric servers to their developers. For those customers that do not have vSphere, or do not need vSphere, or they do have vSphere, but because of the reason that we're going to cover in a few seconds, they think that the next major applications that are based on Docker and containers should not go onto vSphere, but should go on another type of infrastructure. That is where Photon Platform comes in, right? So think about how we're going to show you more about this in a second. But Photon Platform, in a nutshell, is a distributed control plane that works on ESX hosts. I have a picture for that in a second that clarifies this. It's just, I like to call it just enough infrastructure to be able to run those container management frameworks that you have seen before, like the Mesos of the world, like the Kubernetes of the world, and things like that. It's optimized to run those kind of container frameworks and the application that usually you run using and leveraging those frameworks. Right? So if you remember this slide that we showed, and in particular, if you remember this notion here, the HA, the scheduling, the resiliency of the application doesn't need to be delivered at the infrastructure level, but you as the developer or the DevOps team are going to take care of it, and you just need, CPU, memory, and capacity to run those stuff, and you will take care of everything, then maybe vSphere is not the right platform to do that at scale, right? Because you're not interested in ERS, you're not interested in HA, you're not interested in vMotion, and all these kind of functionalities, right? So Photon platform is really, if you will, an alternative solution to vSphere, which I'm picturing in this slide here. So vSphere is, there is a bunch of ESX server, and there is vCenter that manages and drives the behavior of those ESX servers. Very UI-centric, but obviously we do have lots of APIs, and we're enriching those APIs as well. But Photon platform is really something different. There is no vCenter, there is still ESX, because that's the hypervisor that we're using. It is the very same hypervisor. There is no modification or anything, at least at this moment in time. So it is the very same hypervisor. What we're doing is the control plane is no longer vCenter, but it's Photon controller, which is a distributed control plane that we run on selected hosts in your infrastructure. And this is optimized for APIs. We do have an UI for it, but it's really optimized for high churn and deployment at scale, where vCenter is maybe not the right choice for these new kind of workloads and greenfield kind of deployments. That's pretty much what I had, and I tried to be, I obviously ran a bit late, but that's pretty much what I had, and hopefully it gave you enough information on why we're doing certain things and how we branch the message between vSphere integrated container and Photon platform. There will be more to say about this, but in the interest of time, I thought that it was better to give an overview of where the industry is, where we're going, and what we're doing to intersect with the industry. I will be around. Is there any other question? Okay, cool, thank you.